Well, good morning, everybody. First of all, I thank the organizers for this opportunity. This is a paper from Ms. Rini, who is a PhD scholar from VIT University, Vellore. And I'm a field guide for her, and I am presenting on behalf of all the preparators. Previous speakers, this is again about LVRT, but previous speakers, especially Mr. Balasubramanian Fak, has made my job easier because they have elaborated more on LVRT, and especially Mr. Balasubramanian has dealt with LVRT requirements in windmills. But my presentation is not about the LVRT requirements for the windmills. After 2014, anyway, all the new windmills erected should have LVRT as per the new grid codes. But here, the presentation, my presentation is about the LVRT requirements of the existing windmills. Existing windmills, especially type 1 and type 2. Those windmills doesn't have LVRT compliance. It's all started with SRPC, Southern Region Power Committee petition in CRC, stating that even the old windmills should have LVRT, because there are instances where due to grid faults, they withdraw from the grid and it causes disturbances in the grid. Finally, CRC came with an order that old windmills also should have LVRT, barring with stall type installations. But it was given, the job was given to SRPC to identify whether it is possible, then who has to do that. A lot of issues came through the discussions. There was absence of manufacturers. Old windmills doesn't have manufacturers, even the maintenance persons. So who has to manufacture? Then what is the design, technicalities, then finally the commercial issues, all those came in. So I am elaborating on such things. These are all LVRT requirements. I am not going to elaborate on this because everything, it has been elaborated sufficiently. But the old windmills, especially in Tamil Nadu, most of the old mills doesn't have LVRT capabilities, especially type 1, type 2 machines. So additional costs incurred. Then who has to manufacture, the burden of the manufacturers, then policy issues, then commercially, whether it will be compensated through the funds or through the tariff mechanisms. So it has to be decided. A lot of things cropped in, especially the stall regulated windmills has been exempted from this. So if the substation has both a combination of stall and other type of mills, what should we have for that type of substations? Whether we can go for a individual mills compensation or a substation-wise compensation like a StatComs. So everything was deliberated in that. Finally, we requested that from Indian Wind Power Association, we requested that even if we go for retrofitting of the old mills, whether the old mills will be capable of withstanding those kind of fault situations. Because we have recorded some events where it can show that during the fault conditions, there are exorbitant current injected from the windmills to the circuit. That's why originally it has been designed to trip these windmills during the type of faults. Now the question arises, LVRT is a cure. Whether we can have a prevention. Prevention is better than cure. Whether there is any preventive steps for these kind of issues. Whether we can, this LVRT requirement is due to the operation requirement during the low voltage conditions that is created by the fault, anyway fault from the network conditions. But whether we can avoid that kind of faults, whether we can go for some power quality standards for the supply, where other countries have such type of standards. Yesterday, day before yesterday, when CRC chief was explaining, we were not very keen on power quality standards when we were suffering from shortages. Now that we are comfortable with this power supply, whether we will be very keen on the power quality standards to be implemented for the supply side also, so that these kind of issues can be addressed. So investments, all those things. This is a typical event showing the voltage trend in a 11 kV system from exclusively windmill connected substations. Nearly 50% of the voltage sag has occurred. During that fault, nearly 40% of the windmills withdraw from the circuits. But before withdrawing, you can see that large amount of current has been injected into the circuits by the generator. If it is allowed to continue at that condition, what will happen to the generator which is connected permanently to the circuits? Original designers designed the windmills so that during these conditions, the windmills should trip and get away from the circuit, and it will be saved from the damages. Now that we require LVAD requirement for the sake of grid management, yes, it is required. But before going to this, whether this kind of incidents can be prevented, we can go into that and we can fix up some standards like that. That is our requirement. So, grid standards to include power quality for supply like voltage standards. Utility can take steps to prevent this kind of avoidable faults, at least avoidable faults. So there are some manufacturers who are not there in the present scenario, and for such type of windmills, who will be manufacturing, who will be retrofitting the windmills? That is a big question that is to be answered. So even burden on the manufacturer, they have to design it, they have to commercially value it, then come out with the figures, what should be the cost for LVRT retrofitting. Then policy issues, that is already there in the pipelines. Require adequate studies on LVRT retrofitting solutions. Indian Wind Power Association requested to explore a suitable mechanism to meet the incurred expenditure. LVRT not viable for stall type wind turbines. The type wind studies, all other types, studies has to be required whether that type of windmills would be capable of withstanding that fault condition when LVRT is retrofitted. Before retrofitting old mills, the healthiness of the WEGs for fault withstand capabilities to be studied and certified by the appropriate agencies. These are the references. And thank you. Any questions? I am prepared to answer.